I think when we submitted the talk, we put Benjamin's name on the speakers list as well, but it's just me. It wasn't practical to do this in a hybrid form, so I tried to represent whatever Benjamin would have told you. Yeah, about myself, I've been working on GNOME for a very long time at this point. So if you're using GNOME, you probably run code that I've written here and there. It's all over the place, but my home base really is GTK. That's where I work most days, so I kind of want to talk about GTK and present highlights of things that have happened since last GUADEC in GTK. The title of the talk that we submitted was a deep dive about the new renderers. And the new renderers are going to be an important topic, but it's not the only topic. I'll just talk about everything that happened in GTK, and we'll see how it goes. But before diving into technicalities, I want to set the stage a little bit and explain a bit about the environment in which GTK operates and the large-scale organization of things. GTK is split into several major parts. One is GTK, which is the windowing system abstraction. That's where you find the code for the macOS backend and for the Windows backend, for example. Then there's our new rendering system called GSK, which maintains a scene graph for us and translates that into drawing commands. That's a bit newer. We introduced GSK in GTK 4. And then there's GTK itself, which is where the widgets live that applications use to present things on screen. And originally, when GTK started out, the GTK APIs were modeled on X11. That was the windowing system that was en vogue back then. And nowadays, with GTK 4, we try to follow the Wayland APIs to the extent that is practical. So instead of windows, we now have surfaces, and our surfaces don't have global positions anymore. That's just an effect of following what the Wayland APIs do. And for the rendering, drawing in GTK has been done by Cairo ever since Cairo was introduced in the early 2000s. And with GSK being our new rendering layer, we now have a scene graph that we can use to do rendering, and Cairo is kind of getting less important as the drawing API. And the GSK renderers can translate our scene graph, the render nodes, either into GL drawing commands or Vulkan drawing commands. And as a fallback, there's still Cairo if all else fails. For the widget part, the story is a bit different. GTK is a big code base. We have more than 700,000 lines of C code, and there's really only a small group of people who work regularly on it, apart from myself. That's Emanuele, Benjamin, Carlos, Jonas, Christian, who's somewhere here, and a few people who work on other backends like Junwei and Luca on Windows, and Arjun and John for macOS. So that's really a small group of people for a big code base. So we're constantly looking for ways to shrink the scope and have less things to worry about. And one thing we found that kind of aligns well with other goals we have is to try to push the front-end API, the widgets, towards other libraries so that we don't have to worry so much about changing those, and they can develop at their own speed. And the libraries to mention here are examples like libadwaita or Granite for elementary. And maybe eventually this XApps effort might grow their own as well. Collectively, we call these the platform libraries, because that's where the platform user experience is defined, basically. And for us in GTK, that means that we don't have to worry so much about following the latest design trends and keeping up with widget tree that's changing. We can focus more on plumbing and infrastructure, which is a good thing. So if you want to hear about exciting new widgets, you have to go to the Advaita talk, libadwaita talk, if there's one. And I will instead talk about more lower level things, which are still exciting, hopefully. With that, I'll switch to talking about some of the things that have happened since last GUADEC. As I mentioned, GSK has kind of made the importance of Cairo has lessened the importance of Cairo as our drawing API. We now have SceneGraph that takes over from that. And we can even imagine a future where Cairo does not figure it out in our APIs. That is certainly GTK 5 discussions and plans. But to get there, we kind of need to start somewhere. And one thing that Cairo does, it supports path rendering. Paths are basically free-form Bezier curves, and Cairo supports stroking them and filling them. And to get us step-by-step closer to a Cairo-free future, we introduced GSK paths, which basically takes over path modeling, and we also have render node APIs and snapshot APIs that go along with that. So we can do things with paths now without having to rely on Cairo directly. Of course, the implementation underneath is still using Cairo for some things, but at least the API is free of Cairo now. And we would encourage everybody to try it out and tell us what works and what doesn't work, so we can fill the gaps and make a path API that actually lets you do cool things. We haven't seen much adoption yet. I mean, the path API rolled out in GTK 4.14 at the beginning of this year. We do have a few demos in GTK demo. This is a screenshot of one of them. I tried, but I could not figure out how to make videos embed into this presentation, so I just have a still image. If you run this demo for yourself in GTK 4 demo, you'll see that the arrows are like little marching ants. They march around the outlines of the continents, and they change colors as they do. So that's a neat little demo, and maybe give some idea for what you can do with paths. Right, moving on from paths to the next topic. I already talked about that the GSK gives us a scene graph, and the renderers in GSK walk this, it's actually a tree, so they walk this tree and translate the render nodes into drawing commands. And that is pretty powerful. You can do a lot of things with that. But it also introduces some overhead. And there's some situations where you really don't need compositing and translations and effects. One example would be showing video content or image content. Most of the time, you really just want to see the video, and you don't want to have effects on top or UI elements on top. You want to focus on the movie you're watching. And so for that, it would be nice if we could just avoid the overhead of the rendering step and the compositing. And to make matters worse, for video at least, it is often the case that the content actually is already on the GPU side because it was decoded by the video decoding unit of the GPU. And then if we use it in our scene graph, we might have to download the content back to the CPU side to use it for compositing. So that's not great. And we wanted to do better than that. The kernel has APIs that let you handle memory without having to download it. There's something called DMA buff, which is basically the kernel API for identifying a piece of kernel or device memory with a file descriptor and attaching some metadata about the format of the data. And then you can hand it around from one kernel component to the other, possibly through user space, without having to download the data. And last fall, we added support for DMA buff to the texture abstraction that GTK has. And what we also did is we added support for subsurfaces to our Wayland backend. That might get some people excited, I guess, if I mention subsurfaces, but I wanted to say that this is not actually exposed in any APIs. We just use this internally. So if you want to use subsurfaces in your application, you still have to do it yourself. But yeah, I also wanted to say that this is obviously Linux specific. DMA buffs are something that only exists in the Linux kernel, and subsurfaces are Wayland specific. So currently, this is very specific to running Wayland on Linux. It would probably be possible to use similar concepts on other backends, other platforms, but nobody has done the work so far. But with these two pieces together, we have the infrastructure and had the infrastructure in place to actually implement graphics offloading. We added a new widget called GTK Graphics Offload, which creates a subsurface. And then our renderer, when it sees one of those subsurfaces, it attaches a DMA buff that it finds somewhere in the node tree. And thereby, we bypass the compositing step that the GSK renderer otherwise does. And if we get really lucky and the right circumstances are there, for example, the window is full screen, we might even be able to also bypass the compositing on the compositor side. And the compositor might be able to directly use the DMA buff and pass it on to the kernel APIs, which then gives us a zero copy path from decoding the video all the way through sending it from the client to the compositor and eventually getting it displayed on the monitor. It is pretty difficult to take a good screenshot of this because when we added these things to GTK, we worked very hard on making it transparent. So there's lots of things that can go wrong between the kernel and various drivers and GStreamer with DMA buffs. These formats need to be negotiated between the involved parties, and sometimes that fails, or the two drivers don't understand each other properly, and then this offloading fails. And we worked very hard to make GTK, in that case, fall back and just download the content after all and use this in our compositing as normal, so that things just look the same, even if they are less efficient. And for that reason, giving you a good screenshot of how this looks is pretty much impossible. So what I have instead is a little illustration here that kind of shows you how you need to think about offloading. You see the main surface in the back, where GTK renders the window decorations and the buttons in the header bar. And then you have a subsurface that is layered, is stacked above it, where we have attached one frame of the Big Buck Bunny video. And we hand these two things separately to the compositor, and the compositor puts them together so that it appears like one window. And I have another variant of this illustration that shows some of the subtleties that can occur here. In this case, there's actually a control on top of the video, like the play button there. So we cannot just have the subsurface stacked on top. What we do instead is we stack the subsurface below the main window, and then we cut a hole in the main window so that the subsurface can show through from underneath, even after we rendered the button on the main surface. Right, so why do all these complications? This is it's pretty good for battery life, and it reduces power consumption. In particular, if you get those lucky circumstances I mentioned earlier, and your window is full screen playing a video, so we can get direct scan out all the way to the monitor. In that case, maybe the 3D engine of the GPU can be powered off for a very long time while you're playing this video, and we just need to do the decoding for each frame, and then we get a DMA buff, and everything works very efficiently. It's most relevant, obviously, on less powerful platforms like phones that some people like to try and run GTK4 on. But it's faster too. I mean, we just avoid doing a lot of extra work. And GTK4-based video players are actually pretty competitive now. And if you want to see this in action yourself, I would recommend installing something like what's it called, Showtime, one of the newer video players that use these GTK4 features to the best they can. And yeah, just try it out yourself. Moving on to the actual topic of the talk, new renderers. That's the biggest piece of work that has landed since last GUADEC, I would say. When GSK was first introduced in GTK 4.0, we had two renderers. We had a GL renderer, a first generation GL renderer, and an experimental Vulkan renderer. The GL renderer was basically just good enough to get GTK4 out the door, because we had to hit this deadline. We wanted to do less than 10 years between major GTK4 versions, and so we had to release GTK4 in December before the 10-year mark. And so the renderer was just basically good enough. The Vulkan renderer never matured beyond being an experiment that we never enabled by default. For the GL renderer, we did improve it after a few releases. Christian Hurgert who sits there, actually rewrote it and made it a highly optimized piece of code, which is great for running it on less powerful GPUs. It was great for that, but it also made it a bit less extensible. It was just very optimized, and when Benjamin decided to do new renderers, he went back to the experimental Vulkan renderer we still had around, took a long look at it, see what lessons we can learn, and then he started writing a new rendering infrastructure, which is unified. That means we have like the entire abstraction of walking the node tree and translating things into commands, which calls into some abstractions that let us do either Vulkan rendering or GL rendering with the same code base. And that's nice. And some other improvements that we could do while doing all this work is that we now have more capable shaders which do anti-aliased rendering, so we can, as a side effect, actually do proper fractional scaling. And to explain a bit more of what I mean by that, I need to go back a little bit, back in time. Traditional high DPI support, like GTK has been doing since 2014, is just done by rendering everything at twice the resolution. So you get 4 pixels instead of 1. And of course, on your monitor, 100% might be too small and 200% might be too big, or the other way around. And what we can then do is, on the compositor side, we can take that 2 times rendering and scale it back down so that you actually get something like 150%. Of course, that has some downsides, this approach. It makes it so that applications render more pixels than necessary. In particular, if you go beyond 2 times, say to 3 times, you end up in situations where we can actually have bandwidth problems, because that's just a lot of data, and it all gets scaled down on the compositor side again anyway. And the scaling down on the compositor side makes everything a bit blurry. It's very uniformly blurred, but still, applications really want to have the actual scale enhanced so they can render sharp at the device level. And with the new renderers, we were finally in a position that we can actually do that. There's a Wayland protocol that gives us the actual scale that the user selects, and then we can just render at that resolution without producing too many pixels. And in particular, what we can do is we can render the fonts actually at the actual resolution, so we can get font hinting that actually works properly. Before moving on, I forgot to say that there can be some problems still. The Wayland protocol that we use for fractional scaling has some limitations, and sometimes rounding errors make everything blurry again. But we're trying to get a handle on that. Beyond these big headline features that I listed now, there's a few smaller things that have happened since last GUADEC. I wanted to quickly go through some of them. One is we have a new GTK print dialog. That's what the API is called, but I wanted to make it very clear that this is not actually a dialog widget. It's another instance of we have a family of async dialog APIs which abstract away the widget so that you can nicely implement these async APIs on top of platform-specific interfaces. For example, on Windows, you can get a Windows file chooser, or on macOS, you can get a macOS file chooser. And this print dialog API is another one in this family. And on Linux, what we can use to implement these dialog APIs is portals. So this print dialog will talk to the print portal. And you can view this as another way of delegating platform UX questions to the platform, as opposed to doing it inside GTK. Here it's just done via portals. Right, we also we had some gaps in our accessibility story that we closed over the last year. The first item here is that we got a socket that lets WebKit graft the accessibility tree for the web content on top of the GTK accessible tree for the Chrome. That work was done by Georges, who's also here. Thanks for that. And we also now have a accessible text interface exported that lets third-party text widgets be accessible. One example of that is, of course, your terminal, which can use this interface to be accessible and be read by Orca. We also did some small maintenance work on list and column views. Christian, again, tracked down some problems with the GTK expression implementation that caused things to be unreliable if you have more complex expressions. I don't really want to get into the details there. This was something around weak references getting wrong. It should work much better now. That should be good news for anybody having to work with lists and column views. Last thing to mention here is work on CSS color support that happened recently and was merged. We now support a lot more of the modern CSS specs around color and different color spaces, more expressive ways to express colors in your theme. And that lets us deprecate our homegrown named color and color expression machinery, which is good because we don't want to deviate from CSS as it's on the web, if we can help it, because that's what everybody knows. And this work was done by Alice as part of the SDF initiative, so thanks for supporting GTK in that way. Right, now this is the interlude. I was hoping for a curtain to come down here so I can step out and welcome you to the second half of my talk, where I now switch gears and I'll talk about some things that have not landed yet, but are currently in the works and will hopefully show up before too long. So welcome again. I'll just keep going. I talked about accessibility already a little bit, but the big news is still coming here. It's of course no secret that one of the major focuses of the SDF initiative was improving our accessibility story. And Matt Campbell, who was contracted by the SDF initiative, has been working on both a new cross-platform library abstraction for accessibility called AccessKit, and on new accessibility plumbing for Wayland. That's codenamed Newton, I believe. And in a status update, he recently shared that he had GNOME text editor basically 100% accessible on Windows, which is a pretty big milestone because, to my knowledge, we never had an accessible GTK application on Windows before. So that's very exciting. And I hope that the bits and pieces of this work will land in GTK and Matter, where the Newton plumbing needs to live over the next months, and should give us a much better story. And it might also be exciting for some that AccessKit is written in Rust. So if we merge the AccessKit support in GTK, that will be our first Rust dependency. Session saving, that's one of those minor convenience features that you only notice when it's missing. Historically, session saving has never worked well on Linux as a system feature. X11 had a session saving protocol called XSMP, but it was a bit overcomplicated and never really broadly adopted by applications. So applications have, over the decades, taken matters into their own hand. And nowadays, I guess, when Firefox crashes or gets closed in some other way, we expect it to come back the way we left it, basically, because they do save their own state, and that works. It also works for your terminal, whether that's GNOME console or Pytuxis. It'll come back with the same layout that it had, except for one minor problem. Both browsers and terminals are applications where you commonly have multiple windows open, and they may be arranged side by side or something like that. And that part of the state, unfortunately, with Wayland, is not really accessible to applications, so they can't save that themselves. So if you relaunch your terminal, it'll no longer be side-by-side tiled, but those windows are free-floating and you have to rearrange them, which is annoying. And it really only, thankfully, needs a small bit of support to let the compositor save this part of the state for us. We need a protocol where an application can restore a session that it had created before and where it can give an ID to each top-level surface, so we can know which the compositor can know which state it needs to look for in its saved session. And Carlos Garnacho has been working on this. There's a small Wayland protocol that does just this and nothing else. And we have both a GTK branch and a Mata branch. With a bit of luck, we might still be able to merge this for 4.16 and have a better story for session saving. Right. The last item I want to mention here is colors. Benjamin and myself have been working hard on improving support for colors and color spaces in GTK's rendering machinery, with the ultimate goal to be able to display HDR content properly. We have been pretty heads down into this for a month or two now, so I could talk for a long time about all the complications and details of this. I'll try to give a summary without getting lost in the weeds too much here. If you want to know more about this, you can obviously find me during the conference or after, and I'll be happy to talk more about this. So what's the plan? We want to have a color space object in GTK. For some reason, it actually changed its name from color space to color state. I don't know why that happened, but it's just the way it is. And all the colors that we are passing to GSK, to our renderers, will have to be tagged with one of those objects, so we know how to convert the colors into the color space that we want to do the compositing in. The same goes for textures that we upload and attach to nodes in our render node tree. They need to be tagged with a color space as well. And that in turn means that when we are loading image data from files, from PNGs, or when we get image data from GStreamer, we need to somehow acquire information about the color spaces. All this text code, and we have written some of that already. And we are now in the process of connecting all these things. But once they're all connected, it should be relatively easy to take HDR content that we probably get from GStreamer and have it come out right at the other end, which is the ultimate goal. Another thing we can achieve while we're doing this is to allow gradients to use different color spaces. Gradients are a bit different from the other rendering we do, because with gradients we actually interpolate between colors on the renderer side. And I wanted to go into some more depths here. When doing this interpolation, using RGB as a color space is often not ideal. You can see that here on the left side. If you go from a purplish color to a greenish color, and you interpolate in a straight line with RGB, you end up crossing pretty close to the middle where it's gray, and your gradient doesn't look so good if it has a gray blob in the middle. So what you really want to do is use a different color space where you have the hue encoded as in a polar way, as an angle. And then if you interpolate in a color space like that, a straight line interpolating from between the same two colors actually goes in this circle, because we interpolate the hue, which is the angle, so we're just rotating around, and the saturation and the luminosity stay roughly the same. One interesting aspect of this is that when we're doing this in a polar color space, like on the right, we actually have a choice to make. We can interpolate, we can go the short way or we can go the long way. But if we do that, we can actually produce pretty good-looking gradients. In this example here, I'm using the OK LCH color space. The H in there stands for hue, so this is a polar color space where the hue is encoded as an angle. And you can see two gradients here. The one at the bottom, going from red to yellow, is using the short path, and The gradient in the header bar is interpolating between the same two colors, but going the other way around the circle. So that's a bit of expressiveness that we win if we do this work in that color space. Right, all of this work is currently in the process of being merged. We already have the GTK color state object in GTK main, and we are now busy connecting it to other parts of the code. Like we are adding color space support to our PNG loading machinery, and we are we're connecting the CSS colors that I mentioned earlier to the GSK renderer as well. And once all this is done and merged, we can actually show HDR content. In fact, just yesterday morning, Benjamin was on IRC and saying that he actually had succeeded in seeing HDR content displayed properly using this machinery. So that is very recent and exciting. Right, I wanted to say a few more things here about the timeline for this work. As I said, we are merging these things right now. And once it's all done, we want to change our rendering to prefer a linear color space, which is for the compositing, which is a bit of a breaking change, because if you do the compositing in linear spaces, the end result looks subtly different than what we are used to. So we don't want to do this switch at the last minute. We'll do that early in the next cycle, so themes and applications have time to adapt to that. And we can take our time and get it right. And I think that ends my tour of developments in GTK. And all that remains is to see if there's any questions. Yes, Bedard.
When can we get rid of Cairo?
You want to repeat it into the microphone? It's an important question.
Thanks. I'm wondering, when can we completely remove Cairo?
Cairo is exposed in a lot of our APIs. Like let's see. I think the main stumbling block there is things like Cairo region and Cairo rectangle, and all these APIs are kind of baked in. And currently we still have our fallback. Our GSK rendering machinery still falls back to Cairo in the end. So I don't see a realistic path to get rid of all that before GTK5, which is still a bit nebulous. When I was on stage a year ago and talked about the state of GTK, I said, oh, we want to start working on GTK5, and I was convinced that was the right strategy, but over the past of the last year, I showed you a lot of the work that we were able to actually do inside GTK4. So our current thinking is that there's still a lot of development that we can do before we have to open the GTK 490 branch and start heading down the road to GTK5. So maybe that's a bit further away now than it was a year ago. Not the greatest answer, but that is the way it is.
Hi. My understanding was that fractional scaling is only possible with an API break, so it would be delayed to GTK5. But then it happened in GTK4. So is there something missing? Is it like what happened there?
No, there was no API involved in this. I mean, it's really between the application and the compositor to negotiate. I mean, there's no API that we had to break to make this happen.
Okay.
I think you mentioned as part of the CSS improvements that we were able to remove like named color or deprecate named color and things like that. So do we have like CSS variable support now? Or
yes. So I said that Alice worked on CSS colors, but actually what she started out working on first was CSS variables, as you said. Okay. And the colors were only a follow-on. So we do have fully working support for CSS variables now in our theming machinery, which is cool.
And I assume that feeds into like platform theming and such, and those initiatives.
Yeah. So Alice also ported lib advaita, the theme that is shipped in lib advaita to the new machinery. So that's using variables now, but we still define the named colors for backwards compatibility because some application CSS expects them to be there. So it will be a bit of a break if we just drop them outright. So we're gonna have to keep them in place, and then come GTK 5, we can just make a hard cut and say, no more named colors, just use variables.
This is a somewhat quick response to the fractional scaling bit. There is some things that are difficult without an ABI break. For example, we tried to make text view really fast over the years, and especially in the last cycle, we did a lot of work right at the end to make, all of the fonts kind of like jump specifically to the fractional scaling grid. And in one way, that's made the fonts way more readable today, but it's created some other issues with where you scroll, where you might get a little bit of like visual distortion because we're jumping between like the nearest pixel grid as we like move through things. So it kind of gets like this little bit of jitter that for someone like me, I find it quite annoying. But for us to fix some of that is gonna take a lot of time because it's so intricate in the details. For example, right now text view lays out everything on an integer scale. So even though we're like going to render and clip to a device grid in a fractional scaling, the position of all of your lines needs to exist on a actual integer boundary. So we need to change that to using, say, like double precision or something. And to do that, we have to break ABI. We can kind of work around it by just saying like, oh, we're working on such a small number here that like maybe we can add some different API for you to interact with and kind of like deprecate the old one and massage it to seem like it's right. But that's kind of more the type of thing that I think we just need to redo all of our widget origins in GTK 5 without integers. For example, every widget today must have an origin on an integer boundary. And that doesn't need to be that way in the future, but at the moment it is.
Yeah, thanks for that explanation. I was just going to briefly throw in here that I'm giving a talk with Bedard on Saturday about fonts, where we'll probably dive a little bit into some of these topics around GTK's font rendering.
Okay, we'll take this last question.
Yeah, I guess I could have looked myself, but I'm assuming the CSS is all in-house, the implementation of CSS?
What about it? Sorry, I didn't catch the question.
Is it all implemented in GTK?
Yes, GTK has its own CSS implementation, which has been in the works for the better part of 10 years now, I guess, and it has over time matured, and as we just saw, like now it even supports complicated features like CSS variables. So it is obviously never going to be as complete as a web browser's CSS implementation, but it's decent, I would say, at this point, and certainly good enough for our needs and themes.
Okay, so there's no, I'm assuming the use cases diverge. There's no, you were talking earlier in the talk about outsourcing a lot of the stuff to other libraries. Is there space to do that with CSS, or it sounds like it's a very specialized use, so there isn't really any point in that?
Yeah, it's a bit different from the way you use CSS on the web. I mean, we are explicitly not doing layout with CSS, so it's just about backgrounds, colors, borders. And yeah, it's its own flavor of CSS, I guess. And so, but you're right, from that perspective, it might, I talked about the code base being too big, so you could argue for maybe we should just use some CSS implementation from somewhere else, but I don't know, that would be work that somebody needs to do, and so far what we have works and is maybe small and focused enough that you can actually do things like Alice, who came in and became familiar with our CSS code base and then implemented CSS variables within a few months, which is not a small feat, I would say. That was a scary spec for some of the people who have worked on CSS before.
Yeah. Thanks.
Thank you.
All right, just one last sentence. I wanted to mention that the slides and the materials that I used here are available on on GitLab if you want to find them. Thank you.